right about now we're starting to get into calculus. Well, kind of. So x plus x algebra, that equals to 2x. And then we have limit of f of x plus limit of f of x is the same thing as 2 times the limit of f of x. Why did I write it like that? F of x is x approaches c. So the table above gives selected limits of the functions f and g. What is the limit of x as x approaches 1 of f of negative x plus g of x over 2? So as g of x approaches 1, we have 6. As f approaches f of x is 2. So that would be negative 2 plus 6 over 2. Negative 2 plus 3, which would give us positive 1 or just 1. Oh, no. My fault. This is x approaches 1, and this is negative 1. This would be 2. So scratch that. That would be 2 plus 3, and that equals to 5. I knew I was doing something wrong. Okay, so the graph of the function is showing to the right what's the limit as x approaches 4 of f of x. So f of 4 would be here, and f of 4 would be 1. So that's f of 4 equals to 1. And then to find f of 1, as f is 1, f of 1 equals to negative 1 equals to negative 1. Do we get that? Okay, what am I at right now? See, okay, so the table above gives selected values and limits for the functions f, g, and h. What is the limit of x as x approaches 5 of h of x times f of x plus 2g of x minus h of 5? It's a little, it looks like a little, it looks like a lot. But when you actually simplify it out, get the 5. This is 6 plus 2 times negative 1. And then minus 3. So that's 5 into 4 minus 3. 20 minus 3 equals to 17. Can we all see that? My fault. And then, okay. Now we're getting into the piecewise defined functions and limits. So this acts as x approaches negative 5 from the left side. So these would be values that are less than negative 5. So x is less than negative 5. So this would be root 11 minus x. So this would be root of 11 minus 5 equals to root of 6. Or 11 minus 5 actually. So minus 5. Yeah. That's 11 plus 5. That's root of 16, which is equals to 4. And then limit of x as x approaches 5. Let's see that. So negative 5. So 11 minus 5, that's equals to 4. And then from this side, that is negative 5 plus 3, which is negative 8. And then over 5 minus 25, which is 2 over negative 20. That's equal to negative 1 over 10. Negative 1 over 10, and it does not exist because the limit as x approaches negative 5 from the left is not the same as the limit that x approaches negative 5 from the right. This would be the same thing. So as g of x approaches x from negative 1 would not be equal to g of x as x approaches 2. So there should be the limit of g of x as x approaches negative 1, which would be 3 if we substitute in all the values. It would be 10 minus 1, and that's 9 root 9. Root 9 is 3, as we all know. And limit of g as x approaches e from the positive side. That's when x is greater than e. So that is ln e3. So third, and then it does not exist because this is 26 minus 5e squared over 7 is not equal to 3, does not equal to ln 3. So this right here does not exist. That's 1.5 done.